let's have a look at question one. So this is a vector question, and then that's in it. So it should be like variable acceleration. So let's have a look. At time t seconds, where t is more than 0, a particle p has velocity v meter per second, where v is equal to 3t square I. So we can write that as column vector, just easier to see what's in each component. And then minus 6t to the power 1/2 j. So write like this. And we want to find the speed of p at time t equal to 2 seconds. So speed is the magnitude of the velocity. So we straight away we can substitute in t equal to 2 into the velocity equation. Then we have v is equal to 3 times by 2 square, and then negative 6 times by 2 to the power half. So 3 times by 4 is 12, and then negative 6 times by 2 to the power half, that's just root 2. So this is the velocity vector at time t equal to 2 seconds. If we're looking for the speed, that is just the magnitude. So speed is equal to square root of 4 square plus negative 6 root 2 square. So if we put in the calculator, so square root of 4 square plus brackets negative 6 root 2, those brackets square, that would be just 6 root 6 meter per second. That's for part A. And then part B, find an expression in terms of t, I, and j for the acceleration of p at time t seconds, where t is more than 0. So acceleration, that's just the differentiation of velocity. So we just have to differentiate. So a is equal to 3t squared differentiate to just 6t. And then 6t to the power, negative 6t to the power half, we just bring down the power. So negative 6 times by 1/2, and then minus 1 to the power. So half minus 1 is negative 1/2. So simplify that. That would be just 6t, and then negative 3t to the power 1/2. So if you want to write in the I and j form, you can write as a equal to 6ti, and then minus 3t to the power negative 1/2 j. And then part C, at time t equal to 4 seconds, the position vector of p is I minus 4j meter. Find the position vector of p at time t equal to 1 second. So it's about the position. So we know if you integrate velocity vector, you will have the position. So to work it out, we just integrate velocity. So 3t squared integrate, that would be 3t to the power 3 over 3. And then negative 6 to the power half, you will integrate. So plus 1 to the power 3 over 2 and divide by the power 3 over 2. And then plus c. Don't forget plus c. And if we simplify that, 3 over 3 cancels out, so just t cubed on top. And then put the coefficients in the calculator, negative 6 divided by 3 over 2, that would be negative 4 t to the power 3 over 2, and then plus c. So now we need to use the condition to work out c. So it says when t equal to 4 seconds, the position vector of p is I minus 4j. So it just means when t equal to 4, r is equal to 1 negative 4. So if we put in, then we have 1 negative 4 is equal to, so t equal to 4, that would be 4 cubed, and then negative 4 times by 4 to the power 3 over 2 plus c. So to work out the value of c, we can just minus this vector for both sides. So c equal to 1 negative 4 minus, so 4 to the power 3, that's just 64. And then negative 4 times by 4 to the power 3 over 2, that would be negative 32. So if we simplify that, c is just equal to 1 minus 64 is negative 63, and negative 4 minus negative 32 is negative 4 plus 32. That would be just 28. So that's what c equal to. So therefore, the displacement vector or the position vector is r equal to t cubed, and then negative 4 t to the power 3 over 2 plus c, which is negative 63 and 28. Which is t cubed minus 63, and negative 4 t to the power 3 over 2 plus 28. And now we find the displacement vector. So to work out the position vector of P at time t equal to 1 second, so you literally just let t equal to 1 substitute in. So the position is just 1 cubed minus 63, negative 4 times 1 upon 3 over 2 plus 28. We know 1 upon anything is 1, so 1 minus 63 is negative 62. And negative 4 times 1 upon anything is 1, so just negative 4 plus 28, which is 24. Then that would be the position vector of P at time t equal to 1 second.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.